Let's go ahead and look at the next one. We want to solve, again, this equation and determine what the solution set looks like. First things first, we want to get rid of the parentheses. This is going to become a 6z plus 8 equals to, over here we distribute. That'll give us a 6z minus 4 plus 13. I can combine some like terms on the right hand side. Negative 4 and positive 13 would give me a positive 9. The next step would be to try to get the variables to one side. So I would subtract z from both sides, 6z from both sides, and we get the statement that 8 equals to 9. That's a statement that's false, that's a contradiction. Furthermore, it's always going to be false regardless of what the value for z is, because z doesn't factor into this at all. So what that tells us is no matter what z we pick, we will always arrive at a contradiction, meaning there is no solution, and that type of equation we label that as a contradiction. If we look at the next set of problems, these were our formulas. Here we have the formula, came from geometry. This would have been the formula for the perimeter of a rectangle, and they ask us to solve for the variable L. So we want to get L by itself. The first step would be to removing that 2w term. So I could subtract 2w from both sides. P minus 2w equals to 2L. And then I have one more step to get L by itself. I would need to divide both sides by 2. So our final answer is going to be L equals P minus 2w divided by 2. And we can't simplify this any more than what it's written. Even though you see these two 2's that are there, remember the numerator has two terms, a p and a negative 2w term, and the p doesn't have a constant or coefficient of anything divisible by 2, so that's as good as it gets. Let's take a look at the next one. We are asked to solve this equation for the variable t. To get t by itself, we would want to first subtract and get rid of this p term. So I subtract p from both sides. That would be a minus p is equal to PRT. We have one more step to get t by itself. Notice that both this p and r are multiplying to the t, so we need to divide by both of them. On the right hand side, the p's cancel, as well as do the r's, and so we're left with the equation t equals a minus p, all divided by pr. So that's our formula solved for the variable t. In question number 11, it says a basketball court is a rectangle. So if you want to, you can kind of draw a rough sketch on this. It has a certain length and a width. They say that the length is 12 more than the width. Your standard geometry trick would say, standard algebra trick would say, whatever everything is being compared to, let that be your variable. The length is 12 more than the width, so everything's being compared to the width. So call the width x. 12 more than the width would be 12 more than x, which would be x plus 12. They talk about the perimeter, so we should write out the perimeter formula for a rectangle. Perimeter is equal to 2L plus 2W. They tell us that it has a perimeter of 60. We know that the length is represented by x plus 12, and the width is represented by x, like this. So we have an equation for the variable x we should be able to solve. We distribute the 2 in. We get 60 equals 2x plus 24 plus 2x. Let's combine our like terms over there. 60 is equal to 4x plus 24. To get the x by itself, we're going to subtract 24 from both sides. 60 minus 24 would be 36. Equals to 4x. And then one more step to get x by itself, we need to divide both sides by 4. So we get 9 equals x. It's always important in a problem like this to kind of go back and remember what the variable stood for. In this equation, x was the width, so we know that the width is going to be 9 meters. But they also ask us not just for the width, but also for the width and the length. Remember, the length was the width plus 12, so this one would be 9 plus 12, which would be 21 meters. So our rectangle had a width of 9 meters and a length of 21 meters.